So I've been working on this streaming app that basically playing with it off and on for the last year. Found it somebody had, and the idea is it takes a set of network traffic and it creates statistics around little different windows of buckets of packets, and it does that by windowing across the input stream, and then you get a data set where each row represents a bucket of packets that are somehow statistically aggregated, and initially, and because it's streaming. And this is an unlimited amount of data as a network. The idea behind it was to be able to window without actually filling buffers of memory, right? And it turns out a tumbling window is really good for that because you only have one active bucket at a time. And then when you get done aggregating that bucket, you basically delete it and you go to the next one, right? And so you don't have a complicated overlapping structure. So tumbling just means, and there are a bunch of different kinds of windowing procedures you can do on an input stream, on an event stream. And tumbling is kind of the easiest, right? And so the original system actually was a time-based windowing system. So let me bring this up a little bit. I think I can, you know, let's do this and make it bigger. All right. So the original system was a time-based windowing system where you set the maximum amount of time. So the traffic flows through, the window is open for a certain amount of time. All the packets that come in that amount of time are consumed and added into that bucket, right? That window kind of, as it moves. So in this example here, I don't know if you can see this. You know what? Let's make it a little bigger and scroll down a little bit. Okay, so in this one here, you can see, and because packets come in a regular fashion, the number of packets in a given window could vary, right? So we can see here that if we did 3 tumbling windows, right, the next one, it butts up against the previous one, and we had 11 packets, we'd end up with 3 5-second windows, and the first one would have 4 in it, the next one would have 3, and the last one would have 4. Right? So that is a time-based, time-limited, time span-oriented tumbling window to populate my bucket, right? The next one, so that's what this network intrusion software did originally. And it's great, but it feels kind of funky because maybe instead I don't want to do time, I want to have a max number of packets. Like maybe statistically I could have super high traffic and then not much traffic. I would end up with a window that's got a lot of data in it and a window that doesn't. If I wanted the windows to be not time spread, but instead be size spread so that they each had about the same amount of data in them rather than time. So you can do time-based or amount-based. And so in this example here, I actually set the packet-based or the message-based tumbling window limit to 3 packets, right? So that's the middle row. And you can see that we end up with 4 3-packet windows. The last one's incomplete. I don't feel like drawing it. But instead of 3 5-second windows, we end up with 4 3-packet windows. And all the windows represent different amount of time, but they represent the same amount of traffic. And depending on the problem you're looking at, that may be better, right? The last one is a combination. So I actually added this software to the network intrusion software, and you can see this in the GitHub link that'll be on this wiki page. And it is 5 seconds or 3 packets, whichever comes first. So in this case, what happens is we get 3 packets in less than 5 seconds. That resets the counter, right? Actually, that probably should butt up against it. But anyway, that resets the counter. And then we wait either 5 seconds or for 3 packets. And it turns out in this case, we get another 3 packets. That resets the counter. Now we're looking for 5 seconds or 3 packets. In this case, only 2 packets come in 5 seconds. So the third window is 5 seconds long and the bucket only has 2 packets in it because it timed out before it filled up. The last 3 packets go into the last bucket, and that's because the 5-second window started, but the packets came in before the window was closed, and so we end up with 3 3-packet windows and a 5-second window that has 2 packets, right? So we can do time-based, where everything represents the same amount of time. We can do packet-based, where everything represents the same amount of data, or we can do a combo of those so that we don't run really long times, and so a lot of people will run a variant of that. And I can show you how that ends up looking a little different. So this is what I talked about before. This is time-based windowing, packet-based windowing, packet count. I should call it count. You know what? I'm going to change that to count. Note to self, change that to count, write it on my hand. Count, changed, you know what? Change to count. Okay. Okay, wrote that on my hand. And then the other one here is time or packet based. I'll change that to count. Now, so what does that actually mean? So I actually ran this network intrusion data set against a small sample, 38 packet sample that runs in a minute. And what does it look like? So here we have a 5-second tumbling window, fixed window size, right? And so the way this works out, it turns out that over this minute, there's little bursts of traffic, and we're going to end these, the buckets will be empty if they end up, the timer ends up running out. So we get 24, and then there is 10 seconds with nothing, and then there's, we get 4, right? So there's 4 in that 5 seconds, and then there's a bunch of time with no more, and then it's 409, right? So we ended up with 12 packets, and 1, 2, 3, 4 of them had data, 5 of them had data. The others were empty because they had timed out. If we take that same data set and we do a 10-second tumbling window, so now the window span is 10 seconds, we end up with 6 packets instead of 12, which makes sense, right? Because we had 5-second tumbling windows before, and now we're at 10, so the number of packets is in half, and the layout is actually kind of similar, and that's, we have because we had these little bursty sections and empty sections, so we've still got 2 empty time windows and 4 with data in them. So the next one I did was a tumbling packet tumbling, and again, I'll put it as a count tumbling. And in this case, I set the count limit to 4, and then I put a 10-second time limit on it. So it'll go for 4, 4, 4, 4, but if there's 10 seconds without 4 in them, I don't want to wait longer than 10 seconds. And so in this case, we ended up with 11 packets, right? You can see that the first 5 all had 4 within the 10 seconds, and then we had a 10-second timeout, and then we had 4 a couple times again, and then the last packet at the end of the data set. So in this case, we had one time window where we exceeded, one window where we ended up exceeding the 10 seconds without hitting the 4 count. And that's a little different. So the next one I'm going to do is a 20 count tumbling with a 10-second guard. And this is that bursty nature again. Remember, we had that bursty nature before where we have a lot of data up front, then a little bit of data, and then a blank, nothing for a while, and then some data at the end. So in this case, we're going to max out at 20, and then we'll have a 10-second guard on it, so anything will time out after 10 seconds. Now, because there's only 38 in here, we know that we would either have 2 packets with the counts, or we'd end up with a bunch of timeouts. So that's what happened here. The first packet was very bursty, and the rest of them with all timed out never hit 20, which kind of makes sense because we only had 18 left. But they were spread across the rest of the minute, and you can actually see that here, that the 10-second windows roll off. I didn't actually show you this before, but you can see 3142, 3142, 3152. So this one filled up, then we timed out, and then we timed out again because it's another 10 seconds. And then, so you can see that here, right? 02, 12, 22, 32. So you get different behavior in the data set depending on how you set the limit, and that is a tumbling window where the windows are next to each other, not overlapping, that you can use for different types of data, and you can try and figure out which of those fits your data set. I hope that's useful. You can play with this intrusion set with Python and check it out.